As large multicellular organisms, we are perhaps too ungrateful for the way that chance events led to what we are. At any fork in the road of the history of life, we could have taken a very different turn and ended up totally unrecognizable to ourselves today. Many people are completely unaware of just how much randomness has influenced the development of life on Earth. And by randomness, I don't necessarily mean the completely arbitrary propagation of life over time without any competition or displacement. I mean the random nature of a particular clade having been favored at a particular time over another clade which only moments prior to an unprecedented change in environment was clearly the more favored clade. Now, I call them random as the shifts in environment conditions are oftentimes caused by factors which are separate from and largely unmalleable to life on Earth. A well-known example of this is the complete and utter extinction of the non-avian dinosaurs, due of course to the Cretaceous-Paleogene extinction. I imagine a colossal asteroid impact causing the destruction of huge swaths of both terrestrial and marine life certainly would have seemed random to the dinosaurs at the time. Yet this totally random chance event liberated the Earth from the yoke of the dinosaurs, paved the way for the dominion of mammals on Earth. However, another similarly random event had far more wide-reaching implications. Even more so than allowing for the rise of mammals on Earth. This event allowed for the rise of any kind of complex life on Earth. I am talking, of course, of the proverbial birth of eukaryotes. For those who are unaware, eukaryotes are the most basal ancestor to all multicellular life on Earth today. Many of us would have gazed down through microscopes in school and observed dyed tissue samples composed of their individual cells and would have been taught that cells are the most basic unit of life. This is because the term cell encompasses eukaryotes and also the prokaryotic bacteria, which are also considered to be forms of life. However, the cells of any multicellular species as we observe them today are the result of billions of years of cumulative evolution, and as a result are likely not very representative of the earliest eukaryotes. The bare minimum required for a heap of loosely strung together organic material to be able to call itself a eukaryote is as follows. A well-developed nucleus clearly distinguishable from the rest of the cell contents. They must also have what are known as membrane-bound organelles. These are simply the machinery of the cell, if you like. They must be clearly encircled by a membrane which provides the organelle with its own kind of microenvironment, demarcated from the rest of the intracellular space. In this way, it is similar to the aforementioned requirement of a membrane-bound nucleus. And lastly, a eukaryote must also have a proteinous support structure proliferated throughout its intracellular space, known as a cytoskeleton. But as I mentioned previously, these traits are what define modern eukaryotes. So what might the first eukaryote have looked like? Well, it's important to first establish that by this point, bacteria had already been in existence for quite a while, before the budding of eukaryota. It is important to establish this because of the fact that the first eukaryote was actually part bacteria. The theory goes that an early Archean cell was lounging around in the primordial ooze minding its own unicellular business, when, by a chance random event, it merged with/engulfed a neighboring bacterial cell. Ordinarily, this bacterial cell would have been digested and incorporated into the Archean cell's own structure, but for whatever reason, this was not the case with this particular bacterial cell. As time went on, the intruding bacteria acclimated to life in an Archean and developed into what we now call the mitochondria. Since then, the duo were quite literally inseparable, and now we all still have mitochondria tagging along over 1 billion years later. Astonishingly enough, this very same chance random event occurred again, when the freshly new Archaea-bacterium pairing had managed to fuse, this time with a cyanobacterium. Similarly to how the initial bacterial cell had developed to eventually form the mitochondria within the eukaryotic cell, the engulfed cyanobacterium went on to develop into chloroplasts, or at least a chloroplast. And equipped with these new innovative organelles, eukaryotic life went on to sprawl to every surface of the planet and dominate over its contemporary competitors. Eukaryotic life was so dominant, in fact, that it accounts for by far the lion's share of the biomass present on the Earth, and it's not at all close. You could feasibly argue that prokaryotes have also had a very good go at it, and I would be of no mind to object to that. After all, prokaryotes are also present all throughout the Earth. So abundant, in fact, it's quite likely you've never actually been apart from them once in your entire life, possibly not even in the womb. And unless you're a material scientist, they cover virtually every surface you come across on a day-to-day basis. Quite successful then in terms of their spread. Prokaryotes are also capable of living under conditions where the majority of complex multicellular eukaryotic life could not hope to occupy, living up to their namesake of extremophiles. Similarly, prokaryotes have also developed into a wide array of species, with prokaryotes actually vastly surpassing eukaryotes in this regard. But the unequivocal winner of having the most actual physical corpulence on the planet undoubtedly goes to the eukaryotes. And I would argue that this is actually the most fitting vector by which to judge competition. Yes, we may view large complex organisms such as cats, monkeys and elephants as being their own singular individuals, but in reality, they are composed of many multitudes of individual eukaryotic cells. These individual eukaryotes happen to cooperate so seamlessly and with such harmony that they can function as a mega-organism, when in reality this is sort of an illusion. When each of these cells is considered its own individual unit of life, then eukaryotes clearly are the most successful of their pint-sized ilk. But, credit where credit is due, eukaryotes could likely not have gone on to enjoy all the success they do today without the assistance, unwilling or otherwise, of bacteria. The sense of awe at the probabilistic developments of life and how it could have all gone so differently if the membranes of archaea were simply too non-porous to allow for the absorption of bacteria, or if the cyanobacterium had instead been viciously disintegrated by archaean digestion, has always struck me when I take a stroll down phylogeny lane, so to speak. When you consider that at each node of speciation from the very beginning of life to the modern-day struggle for survival in Earth's wilderness, life could have yielded just an unfathomably large array of species, had the metaphorical dice roll of the universe landed only slightly differently.